Welcome folks. In this video we are going to have a journey through Science Paper 2 for the year 2020, and we are just going to focus on section B of the same paper. We'll have question 1. The diagram below shows the setup of apparatus used to investigate the products of a burning candle. So we have the setup here, and we can see the burning candle, which is we have the combustion process. Then this combustion process is producing products that are passing through this tube into this, then up to the suction tube where we have lime water. Now let's have the first question. So the first question is, why is the U-tube surrounded by ice cold water? So let's look at the products that we would expect to have whenever the candle burns. So under the candle, we need to know that the compound that we have under or part of the candle is the organic compounds such as the hydrocarbons. For instance, let's say we have methane as the reactant. Then whenever we are looking at the burning, it's a reaction with oxygen. Then the product is carbon dioxide, which is a gas. Then water must also be produced in form of also a gas. So the two products that we are expected to have here is carbon dioxide and water, and these two are in gaseous state. Now the reason why the U-tube is surrounded by the ice cold water, this is working as a condenser. So there should be a substance that must be condensed, and to condense is a change from gas to liquid. So the substance that can undergo condensation is this water vapor. So say to change water vapor back to liquid. Right, so we move on to question B. Name the colorless liquid. So the concept here is that there are two gases that are passing through this U-tube here. Then these two gases will have carbon dioxide and water vapor. Now because of the cooling in this U-tube due to the presence of ice cold water, then the water vapor must be converted back into liquid, then forming this colorless solution. Then the carbon dioxide will proceed to lime water. So that's the principle that we have here. So the liquid that we are expected to have here is water. Then say what happens to the lime water in the test tube. So the lime water will turn milky. Right, we'll now move on to question D. Name the elements found in candle wax. So we have the hydrogen, then we also have carbon. Then explain how you can confirm the identity of the colorless liquid. So this is the same as give the identity test for water. So we can say by putting the colorless liquid into copper 2 sulfate. So whenever you put water in the presence of copper 2 sulfate, then the copper 2 sulfate will change to blue color. So whenever there is blue color, then this indicates that the water is available. So to summarize, what we are looking at is the identity test for water is copper 2 sulfate, and this changes into the blue color. Then we move on to question B2. The diagram below represents a paper chromatogram of 3 sugars K, M and N. Right, so this line is our starting line because it's where these components are starting from. Then state the most soluble sugar. So the most soluble is the one with the greatest distance, or the one that has moved the greatest distance from the starting line. So if we compare the distance for this component N, this one is the greatest, then this one is the shortest, then this one is in between the two distances. So the answer for this one is N. Then on the chromatograph above, indicate the solvent front. So the solvent front indicates the height at which the water has, or the liquid that you are using has reached. So this is our solvent front. Right, so we move on to question C. The 3 sugars K, M and N are colorless. What should be done to the chromatograph to make them visible? So we can just add the locating agent where they now show the color change. So say sprinkle a locating agent on the paper chromatogram. Then we move on to D. Explain how chromatograph can be used to identify false banknotes or forged paper money. So say inks from original banknote forged banknote so say are both place on chromatogram, just say chromatograph paper. So whenever these two, the inks from each note, the forged and the original note, are put on the chromatograph, so they will differ in terms of the movement of the color. So the difference in terms of the movement of the colors will determine that one of the two notes is a forged one. So say now after some times, so the inks will move or separate, at different speed. Okay, we move on to question 3. The grid below represents part of the periodic table. State it and answer the questions using the letters. The letters are not the actual symbols of the elements. Now the first one, question A, an element V has atomic number of 7. Indicate the position of V on the grid. So first we'll begin by identifying the groups. So we'll have group 1, group 2, 3, 4, 5, 6, 7, then this is our 8, right? So if you want to look at the group in which an element is found, you need to consider the number of electrons in the outermost shell. Then for the period, you just have to count the number of shells an element has. So we can now write V. So the first shell must occupy 2 electrons, so we put 2 electrons. Then if we subtract 2 from 7, we have 5 electrons in the outermost shell. So 1, 2, 3, 4, 5 electrons. So if we have 5 electrons, this element V is going in group 5. So group 5 is this one. So we have identified the group, then we need to identify the period. So it's like we are plotting the group comma period. So this is the period 1, 2, 3, 4, and 5. So because we have 2 shells, shell 1, shell 2, this is in period 2. So in period 2, this is period 2, then group 5 is here. So this is where our V is. Because on this one, it is corresponding to period 2 and group 5 of the periodic table. Now we move on to question B. Explain why the atomic radius of E is bigger than that of R. Now if you look at these 2 atoms, they are all coming from the same period, but different groups. Now if we are to look at the element E, we'll have this is coming from group 6, so we'll have 6 electrons in the outermost shell. Then if you look at R is coming from group 7, so here we are going to have 7 electrons in the outermost shell. So remember, each atom has the nucleus, which is the one that we consider as the center. Now on this nucleus we have protons. Even here we have protons. So these electrons are attracted toward the center of an atom. So now the concept here is that where you have more electrons in the outermost shell, the force of attraction will be greater than this one. So in this R, there is a greater force of attraction between the protons and the electrons compared to this. Because of this, then here the radius of this one would be smaller than this one, because on this one the attraction is not as this. So what do you mean by the attraction? These electrons, this one is pushing down, this one is pushing down, this one is pushing here, this one is pushing also this. So because of the pushing, we can now, I'm sure we can visualize the outermost shell is becoming closer to the center. Because of coming closer to the center, then the atomic radius is getting smaller. Now since the force of attraction in R is greater than in E, then it's not the same. The electrons are not attracted to the protons on the same rate. So that's a point that we can give. So we'll say E has, so let's just begin with R. So say R has a greater attraction, between valence electrons and protons. Thus, reduction in atomic radius. Right, so we move on to question C. Under question C, which element has the highest tendance to gain electrons? So we are looking at elements or atoms that are more electronegative. So the electronegative is a bit of electrons and to be gained, or maybe the elements to gain electrons. So for this one, the most electronegative are those from group 7. So group 7 are these. So it's R. So we'll go with R. Then select the most reactive metal. So the most reactive metal are those in group 1. Then according to the trend in group 1, as you go down the group, their reactivity increases. So it's C. C is the most reactive metal. So we have C. Then E, write the formula of a compound formed when B reacts with E. So B and E, now we need to look at the valence. So for B is coming from group 1, so has valence 1. What of E? E is coming from group 6, so has valence 2. Then we cross these numbers. So we have B2E. Right, we move on to question 4A1. Define concentration. So we are going to say this is the number of moles of solutes per cubic decimeter. Which is the volume. Then state the SI unit for concentration. So concentration is given in mole per decimeter cubed. Then we have question Roman number 3. Calculate the mass of potassium hydroxide that needs to be used to prepare 500 cubic centimeters of 0.25 molar solution in water. So mass is given by this formula, number of moles multiplied by molar mass. So which tells us that we need to find the number of moles. Then the molar mass will be gotten from this chemical formula. So how can we find the number of moles given this? So say number of moles is equal to, we have the concentration is given 0.25 times the volume. Now for volume, we need to change into decimeter cubed, and we are going to use this conversion factor. 1 decimeter cubed is equal to 1000 cubic centimeters. So to convert from decimeter cubed to centimeter cubed, you multiply by 1000. Then from centimeter cubed into decimeter cubed, you divide by 1000. So that's the simplest way we can look at this one. So let's proceed. We have number of moles is equal to concentration is 0.25 times the volume is 500 over 1000, so that we change. So if you 500 divided by 1000 is 0.5, so 0.5 times 0.25, I'm getting 0.125 moles as my final answer. Then I can proceed by mass is equal to, the number of moles is 0.125 times then we need the molar mass. So the molar mass is Mr is equal to potassium times 1, we only have 1 atom, plus oxygen multiplied by 1, plus hydrogen multiplied by 1 as well. Then the mass number for potassium should be 39. First, let me check on my periodic table. So we are expected to have 39. Okay, yes, it's 39 multiplied by 1 plus 16 times 1 plus 1 times 1. So 31 times 9 is 39. 16 times 1 is 16 plus 1. So 39 plus 1 is 40, plus this one will give us 56 grams per mole. Then this is the number that we are going to put here, 56 grams per mole. So grams per mole. Then here we have mole, so this mole will cancel. then our final answer will be 0.125 multiplied by 56. So I'm getting 7 grams as my final answer. Right, we move on to question B. Construct a balanced chemical equation and its ionic equation for the reaction between potassium hydroxide and the sulfuric acid. Include state symbols. So we'll begin with the chemical equation. For potassium hydroxide, the symbol is KOH. Then this is in aqueous phase, plus sulfuric acid. We have 2 here, SO4 aqueous. Now we know that the product will be potassium sulfate. Then the sulfate is a radical with the valence of 2, so we are going to put a 2 here, plus water. So it's a reaction between a base and an acid, so that's why we are going to have salt and water. Then we just have to look at this equation. So how can we balance this equation? We are going to first balance potassium. We put 2 in front of potassium hydroxide. Then 2 atoms of potassium, 2 atoms of potassium. Then from the potassium hydroxide, we have 2 atoms of hydrogen. Then also 2 atoms of hydrogen from the sulfuric acid, making in total 4. So we need to put a 2 here so that we have 4. Then oxygen, we have 4 atoms from potassium sulfate plus 2 from water, giving us the total of 6. 2 from potassium hydroxide, 2 from sulfuric acid, giving us the total of this. So our chemical equation is done. Now let's move on to net ionic equation. So begin by breaking those in aqueous solution. So potassium has a valence of 1, so put plus 1. Then hydroxide 2OH minus aqueous plus sulfuric, hydrogen is positive, aqueous. Then these 2 here, you bring it in front, plus SO4, it's minus aqueous. Then we are going to break potassium sulfate. We put a 2 plus. So after we've done this, this is our overall ionic equation. But for liquid water, we don't have to break into ions. This is a covalent compound. So this is the overall ionic equation. But our question is, we want the net ionic equation. So we are going to cancel the spectator ions, those ions that are both in aqueous, that are in aqueous state on both sides of our equation. So potassium is in aqueous, even here is in aqueous, so it's a spectator. Then sulfate is in aqueous, also here is in aqueous. So the overall net ionic equation is 2OH minus aqueous plus 2 hydrogen plus aqueous, then giving us 2H2O. Then if we want, we can cancel these since we have the same numbers. Then our final answer is hydroxide ion aqueous plus hydrogen ion aqueous, giving us the H2O liquid. So that's our final answer. We now move on to question 5. When excess magnesium powder was added to 100 cubic centimeters of 0.5 molar copper 2 sulfate solution in a plastic cup wrapped in cotton wool, the temperature of the solution rose by 5 degrees Celsius. So here we can see that the rise in temperature is indicating that heat is given out. So if heat is given out, then the type of reaction that we are dealing with is exothermic reaction. So exothermic reaction is what we are dealing with. So exo simply means out, thermic has to do with heat energy. Then suggest what was used to determine the rise in temperature, thermometer. we move on to question. Describe what was observed when magnesium was added to the solution. So the color of the solution changed from blue to colorless. Then we go to Roman number 2. So Roman number 2, the color of magnesium changes to red brown due to the presence of copper. We know that the color or colors associated with copper is red brown. So say the color of the magnesium changed to red brown. Right, then why is the plastic beaker wrapped in cotton wool during the experiment? So we'll say for easy observation. For easy observation, so that we are able to see clearly. Then how many moles of copper 2 sulfate are present in the 100 cubic centimeters of this? So we have been given the volume. What else do we have? So we also have the concentration. So whenever you are finding the number of moles given concentration and volume, the formula is number of moles is equal to concentration times volume. So the concentration is 0.5 moles per decimeter cubed multiplied by the volume is 100 divided by 1000. So remember, we want to change into decimeter cubed, so that we cancel this. So here we are going to have 0.5 moles multiplied by 0.1. This will give us 0.05 moles. So these were the moles of copper 2 sulfates that were present in the 100 cubic centimeters solution. Now we'll move on to question 6. Greenhouse gases pollute the air. Chlorofluorocarbons, CFCs, are greenhouse gases. Name 2 other greenhouse gases found in the atmosphere. So look at the carbon dioxide. Then the other one, we just look at methane. Then set the respective origins of each of the gases named in. So for carbon dioxide, from complete combustion of, we say, hydrocarbons. Then methane can be produced from cracking of alkenes. Then he describe how the presence of CS in the upper atmosphere increases the amount of ultraviolet light reaching the Earth's surface. So in between the Earth and the Sun, there is the layer, or maybe there are layers that reduces the light from reaching the ground. So if these layers are destroyed, then we are expected to have a rise in temperature. So how the presence, so we'll say this destroys the ozone layers. So destroys the ozone layers, resulting in penetration heat. Okay, now we go to question 7. The diagram below shows an arrangement of outermost electrons in a molecule of a compound. Then A1 on the diagram indicate a double covalent bond by putting a circle around it. So how do you know the double bond? So the double bond is known by 4 electrons. So we need to look at the bond where we have 4 electrons. So this is where the 4 electrons is. So that is the double bond. Then where there are 2 electrons is a single bond. So this is a single bond, single bond, single bond, single bond. Even here single bond, single bond, single bond. So 2 electrons indicates a single bond, then 4 electrons indicates a double bond. So that's how we identify that. Then construct the chemical formula of the molecule above. So we need to look at this carefully. So there is this carbon bonded to 3 hydrogen atoms. So we are going to do as wise. So say CH, then we put 3. Then there is this carbon bonded to oxygen, this oxygen atom here, another oxygen, this one, and the hydrogen, this one here. Then calculate the molecular mass of the molecule. So say Mr. is equal to, we have 2 atoms of carbon, so carbon times 2 plus hydrogen times 4, 3 plus 1, then plus oxygen times 2, giving us 12 times 2 plus 1 times 4 plus 16 times 2. So giving us here we have 24 plus 4 plus 32. So if we add 24 plus 4 plus 32, I'm getting 60. Right, we move on to question B1. To which homologous series of compounds does the molecule belong to? So this is a carboxylic acid. Why? Because of the Cu. Then state one chemical property of the molecule. So say it has a sour taste. Then chemical property, the other one, we can say it can react with a metal to form salt and hydrogen. Okay, so that is what we can look at. So that's it for this video. Thanks for watching.